Hi, everybody, and welcome to this week's episode of Echo Live. My name is Anna, and I'm coming to you from the Michigan Science Center's Echo Distance Learning Studio. This is another episode where we're going to talk about one of our favorite topics here at the Michigan Science Center. We're here to talk about space. Now, today we're going to be building a scale model of the solar system that you can actually fit inside your own pocket. Take it with you, tell people all the facts that you know about the lovely planets and other objects that we know are part of our solar system. Now, we're going to be creating this using a pretty long strip of paper. So for my pocket solar system, I've cut a 3-foot long or 1 meter long piece of receipt paper. Now, if you don't have any receipt paper lying around home, maybe you could repurpose something like a CVS receipt, because I know that mine usually come about longer than this. But you could also tape together some different sheets of paper or use a smaller sheet of paper for your pocket solar system. Now, we said this is creating a scale model. So what exactly does that mean? Well, this activity was actually created by the NISE network, which created this activity to teach us about the relative size and scale of objects in our solar system where planet Earth lives, or where the solar system that we call home. Now, there are various ways to talk about scale inside our solar system. Now, I'm going to go ahead and show you one example of a solar system model. Now, just about nothing in this model of the solar system or this diagram is to scale. Scale means that it would accurately depict the relative sizes or distances between the sun and the other planets that we call part of our solar system. So nothing in this diagram is to scale. According to this diagram, Jupiter is almost as big as our sun, which we know is not the case. We know that planets have various sizes, that Jupiter is a much larger planet than planet Earth, where we live, and planet Earth is a much larger planet than, say, Mercury, the closest planet to the sun. So this diagram is not to scale at all. Now, some scale models of the solar system will do kind of what we just described. They will correct the relative scale of the size of these various planets. So this is a little bit better of a description or a depiction of the scale of the planets in relation to the sun and to each other. But for the purposes of today's pocket solar system, we are not talking about the scale of the size of our planets. Instead, we're going to focus on the distances between them. Now, for this, like we said, we're going to be laying this out on my very long strip of receipt paper here. So we need to kind of outline where the start and stop of our solar system is going to lie. So for this, you'll need your long sheet of paper, and then you'll also need some sort of writing utensil. So I have a Sharpie marker here, but I definitely actually recommend a pencil for this first step, because in the first step of our pocket solar system, I think that everyone should guess where they would lay out everything in their solar system according to what you think is the scale of the distances between those different objects. So the first two things I'm going to put on my pocket solar system are the innermost and the outermost edges of our solar system. So way over here on this side of my receipt paper, I'm going to put kind of a big line similar to what we saw in that last diagram with all our planets. And I'm going to say that this end way over here, this is the sun. So I'm just going to label that here. Again, this side of my receipt paper, the first side of my receipt paper, is just going to be my best guess where I think these planets live. So if we've got the sun all the way here on this edge, maybe you can tell me what you think goes on the other edge. So the outermost part of our solar system here, I am going to write some big words here, or some funky spelling words. But on this end of my paper, I'm writing Kuiper Belt. If you're not familiar with the Kuiper Belt is a belt or a line or ring of asteroids that surrounds our solar system. So we've got Kuiper Belt way over here, which we are going to regard as the edge of our solar system. And we've got the sun all the way on the other side. So if you're doing this activity at home, what you want to do now is you want to think about something like our scale of or the order of our planets, which we know fall between the sun and the Kuiper Belt. And I want you to just go ahead and guess where you would put those on this sheet. Remember that we're trying to guess the distances between these planets in relation to the sun and relation to the Kuiper Belt. So we probably know that there are 8 planets in our solar system. And at some point along the way, there's also something that we call the asteroid belt. So keep those in mind. If you're following along at home, just go ahead and you can either write down letters. So I'm going to start here with planet M for Mercury. And then I think that I would put Venus, maybe somewhere right here, Earth, Mars. How far away do I want to put Jupiter? Jupiter is our largest planet, so I'm going to put it somewhere in the middle of our solar system here, knowing that it's the 5th planet from the sun. I've got 3 more to place on here, so S for Saturn, U for Uranus, and N for Neptune. All right. So hopefully if you're following along at home, either after our Echo Live episode is posted, hopefully you've outlined according to your diagram where you think those various planets are going to lie. Now I'm going to go ahead and give you a little bit of a closer view here. So I'll zoom back down on my table and you can see that I've just written down my planets in order. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then way on the end is our Kuiper Belt. All right, that is where I've guessed I would put the planets if I were laying out the distances according to scale. But let's go ahead and find out the answer. Now I have a really interesting folding guide here that's actually going to help me create the distances between our various objects by just folding this paper in a very distinct pattern. So for mine, I actually have this fun little pack of stickers that I'll be placing on my sheet. So all I've done is I flipped over my sheet so that my sun is still going to be on one side. So when I flip it over, we have sun right here, and I'm just going to go ahead and put down my stickers from my sticker pack. And this one is for the sun. Now, of course, if you don't have fun solar system stickers at home, challenge yourself to get creative. You can use different colored markers. You could print off photos. You can use anything you'd like to create your pocket solar system at home. So I've got the sun on one end, and then just like we did before, way over on the other side, on the back side, I'm just going to place my stickers for the Kuiper Belt, this other asteroid belt that's the outside of our solar system, according to this diagram. Now we're going to start folding. And as we fold, on the various creases that we create, that's actually where I'm going to start putting down some of those planets inside. And then I'll get to compare them as I go with where I guessed where these planets would lie from the innermost side to the outermost edge of our solar system. All right, so my first instruction says to take this piece of receipt paper and fold it in half. So when you do that, you just go ahead and create a crease right here and open it back up. And my instruction sheet says that on this centermost crease, that is where I should put Uranus. Interesting. Now, I'm going to check my responses at the end, but right now Uranus is exactly in the center of the sun and the Kuiper Belt. All right, so very interesting. I'm not sure how accurate I was with the placement of that planet. So now it says to unfold and fold again. So fold again and then fold it in half one more time. So folding now from Uranus and then creating another crease here. And when you open it back up, we should be placing Saturn on the innermost crease, the one closest to the sun. And we should be placing Neptune on the outermost crease, the one closer to the Kuiper Belt end of our receipt paper here. All right, so now we take step 4. Step 4 says to fold the sun to meet Saturn. So we'll go ahead and do that. I've got my sun sticker over here, folding it to meet where I have Saturn on my sheet and creasing. Unfold, and that crease represents where Jupiter falls inside our solar system. And as I'm doing this, I'm realizing that where I thought the scale of distances between these planets would be, that I was really not very close at all, but maybe you had a little bit better luck. So now if we fold the sun to meet Jupiter and crease right there, open it back up, this line right between the sun and Jupiter, this crease is where we're placing our asteroid belt, so not even one of our planets. And man, am I running out of room in the innermost edges of our solar system here. Everything pretty close to the sun. All right, now I'm running out of space, but the folding guide has a few more instructions, and we still have 4 more planets to place according to my sticker guide here. All right, so now when we fold the sun to meet the asteroid belt, that crease represents the planet Mars, the red planet. So the red planet is halfway from the sun to the asteroid belt, and the asteroid belt marks the line between the terrestrial planets and the gas giants, which are farther away from the sun. Very interesting. All right, now with the very limited amount of space that I have left, we are going to take the sun and fold to Mars, and then we're actually going to fold in half one more time. And wow, did I not leave a whole lot of space here on this edge of the paper? Who knew that these terrestrial planets would be so close together? There are so many creases between the sun and Mars in such a small amount of space. Now, on those 3 creases, we are going to put our 3 innermost planets. So Mercury, closest to the sun, and according to my diagram, they're touching, but we know in real life that they're not actually touching. That would be very, very bad. Then we've got Venus, the second closest planet to the sun, but actually the hottest planet, fun fact. And then, of course, our favorite planet, the one that we get to call home, planet Earth. Now take a look at our diagram. Right here next to the sun, we've got 4 planets in just about an inch of space on my receipt paper here. And then from that point on, the distances between our planets get greater and greater and greater and greater. Now you can probably even see through my sheet that my guesses about where these planets would lie are really not very good. I came pretty close with Neptune, thinking about where Neptune might lie. So here's my N for Neptune that you can see through my paper here. And this is actually the planet Neptune according to my sticker guide. So got pretty close there. But I guess that Uranus would be much closer to Neptune than it actually is. Uranus is right here, which is where in my best guess, I had actually put the S for Saturn. So it wasn't very close there. Then I guessed about this far along, I would have planet Jupiter. And planet Jupiter, I have way further out than even where the actual location of Saturn, our ringed planet, is. And you can see that as I get closer and closer and closer, my guesses just get less and less accurate. And that's because the distances between things in our solar system are much greater than we could possibly imagine. So if we head back to our PowerPoint very briefly here, we know that the distances and the sizes of these objects can sometimes be quite deceiving, the way that we see them on paper. The scale model that we created shows you about how far away these planets would be in just this 3-foot distance. But we know that there's all sorts of other objects in and around our solar system as well. Outside of our solar system, right, there are also other stars. The closest star to our star, the sun, the next closest star is called Proxima Centauri. Proxima Centauri is the next closest star to our solar system. And if we wanted to add that to our pocket solar system diagram here, Proxima Centauri would actually have to be 4 miles away, 4 miles of receipt paper. I'm not sure even CBS gives receipts that long. So 4 miles away would be the next closest star according to this very tiny scale model. So the distances between our planets are very, very great, which means that the time it takes us to travel to various planets is actually a very long time. Now, our closest neighbor in the solar system, our closest neighbor you might know is the planet Mars, which is why we are so interested in exploring this planet Mars, since it's the closest neighbor that we have. But if we were to travel to Mars, you might know that it takes up to 300 days to get there, depending on where Mars is in its orbit. The closest it could possibly be is about 150 days time to travel there, but it can be up to 300 days depending on what time of year and where the 2 planets are in their orbit around the sun. Now, if we wanted to get to the largest planet in our solar system, Jupiter would take us 600 days, so double the amount of time to travel to Jupiter than to get to Mars. Now, we unfortunately did leave off our favorite dwarf planet, planet Pluto. But if we wanted to travel to the dwarf planet Pluto, which is not one of our 8 planets, true planets in our solar system, it would take us over 12 years. So understanding the scale of our solar system also helps scientists and you to understand where we lie in the solar system, but where we also lie in our universe, every galaxy that surrounds us as well. So I hope that you had a chance to create your own pocket solar system at home. We'll also be linking a guide to the folding instructions in case you'd like to see a printed out version of those instructions rather than listening to me instruct you here on Echo Live. But of course, thank you everyone so much for joining for today's episode. We'll be back here next week with another episode. We'll be here every Wednesday at 2:30, bringing you fun science activities, research, and guest speakers for the rest of the year. This is all possible because of our sponsors, Denso and the Michigan Space Grant Consortium. So big thank you to our sponsors for allowing us to bring you Echo Live for the rest of the year. We hope we'll see you back here next week and have a great rest of your day.